Hello, my name is Junu, and I'm a PhD student at the Stevens Institute of Technology. I'm going to be presenting on the role of each leg in generating linear and angular impulse in baseball pitching. One of the prevailing questions in baseball pitching biomechanics have been the role of each leg plays in delivering the pitch. From previous research, the back leg is generally seen to be more responsible for the linear components of pitching, while the front leg is more responsible for the rotation components of pitching. We know mechanically, an angular impulse applied about the body's center of mass is what ultimately drives the change in the body's angular momentum. Therefore, this leads to our research question of what are the roles of each leg in generating whole body linear and angular impulse. We hypothesize that the back leg generates forward linear impulse, front leg generates backward linear impulse, and that the front leg generates more angular impulse than the back leg. We have 4 pitchers competing at the minor league level, pitch 6 to 11 fastball trials in the lab. Their center of mass location is calculated via motion capture, and their force data is collected on a practice mound instrument with adjustable force plates. Here's a diagram that shows the axis conventions with positive X going from the mound towards the home plate and positive Z going vertically. The red arrows show the ground force vectors coming out of the back leg, and the blue the front leg. The phase of interest goes from the start of the pushing phase when the back leg branching force Z decrease before increasing to its peak value and finish at ball release. The variables of interest are the X linear impulse, which is the integral of ground action force X, or the forward-directed ground action force. Then, a moment applied about the body's center of mass is the cross product of the position vector, which goes from the center of mass to the center of pressure, and the ground action force vector. And a positive Y moment will serve to rotate the body in the clockwise direction as shown on the screen here. The Y angular impulse is then the integral of the Y moment per t-test, and then used to compare the impulse values generated across legs and within subjects. So here's the time series plot for the back leg ground action force X and moment Y together, where we go from the start of the pushing phase to double support and then ball release. The key thing to note here is that the increase in the moment Y occurred only after the ground action force X reached its peak value and started decreasing into the negative. This signifies the role of the back leg transition from linear propulsion to rotation generation. For the front leg, we see the majority of ground action force X being in the negatives, and moment Y becoming positive shortly after ground contact and before ball release. For the impulse value, we found that the back leg generated positive and front leg generated negative X linear impulse, leading to a net positive X linear impulse, which moves the body center of mass forward. This trend is consistent in all pitchers. We also found both back and front leg generated positive Y angular impulse, with the back leg generating more Y angular impulse than the front leg in 3 out of 4 pitchers. This is surprising because we do not expect the back leg to contribute as much, if not more, than the front leg in generating whole body rotation. So in conclusion, we uncover the role of the back leg in generating whole body rotation in baseball pitching. We'd like to thank MLB for funding and pitchers for participating.